For amide reactions, we are going to limit the reactions to hydrolysis. And hydrolysis can happen either in presence of an acid or in presence of a base. So water is there, but it depends. What's your medium? Is it an acid or is it a base? Okay, so water is going to be there in the reaction. So you have here water in the reaction. And to know if your medium is acidic or basic, then you would need to look what is coming with water. So if you have an H plus in there, then that is going to be an acid. So your medium is an acid, okay? And if your medium is an acid, then your product has to be an acid. If you have a base, then it's going to be an OH in there. This means that your medium is a base, then your product is a base, because always your product is in the medium that it is in. You cannot have an acid in a basic medium, and the opposite is true. So pay attention always to the medium that you are working with. This is called hydrolysis. Hydrolysis means I'm using water. So this reaction here, it's hydrolysis. I know it's H plus, so this means that it is in presence of an acid. I know that I'm going to end up getting an acid. Since I'm using water, then it's going to be a carboxylic acid product in there. Okay, now for these types of reactions, what am I doing? What I'm doing here is that I am breaking the amide bond. We're talking about amide reactions. So you start with an amide and you react it with water. So you're going to break the amide bond. And when you break the amide bond, normally when we react water and H plus, these two, we are going to form H3O plus. So we're going to form H3O plus, which we call a hydronium ion. Okay, this is a lone pair and a positive charge in here. Okay, so when you break this bond, we're going to replace the NH2. We are going to go ahead and replace it by an OH. From where did we get the OH? We got it from here. So we're going to replace the NH2 from the OH of the hydronium ion. So my product here is going to be an RC double bond O and an OH. So again, that OH comes from the reaction of water in presence of H plus. Plus, whatever is left over from the hydronium ion now, it's going to add to the NH2. So I already have NH2 here. Okay, and I do have my two hydrogens that are left over. See those two hydrogens in here? Those two hydrogens are going to come and add over here. So let's go ahead and highlight them with the same color in there, and you're going to end up having a positive charge on the nitrogen in there. So your product ends up to be a carboxylic acid. So the point here is that when you do hydrolysis of the amide, whether you are working with a primary, with a secondary, or with a tertiary, then that part, see the RC double bond O, it's going to turn into a carboxylic acid. And the leftover from the amide, which is the N and whatever group that you have on the nitrogens, not necessarily hydrogens, depending on the identity of your amide, that is going to group up with the two hydrogens that you have left over from the hydronium ion and will give you your byproduct. Okay, let's have an example. So over here, I have an example of a secondary amide. So the first thing that you would need to do is break that amide bond. Okay. Go ahead and take that part of the amide, which is the CH3, C double bond O, and add the OH to it. So you all know now from where did we get the OH? We got it from the hydronium ion plus, okay, if you want, you can go ahead and draw the hydronium ion in there. So that OH is added. Let's highlight that. So this OH over here, let's use a different color. Okay. So that OH is this one there. Plus now the leftover hydrogens. So these are the two hydrogens that are left over. I'm just going to go ahead and add them to the nitrogen here. So the nitrogen will have 3 hydrogens now. So I'm going to have, already I have a hydrogen on the nitrogen, and I'm going to add 2 more in there. And then I'm going to have my CH3, and this is going to be my plus charge. These are the hydrogens that it's going to be any one of those. It really doesn't matter. So these are the ones that I added, and my product is again going to be a carboxylic acid. Again, my product needs to make sense with the medium that I am working with, and since I am working with an acidic medium, then my product is going to be an acid. Hydrolysis of amide in presence of a base. Now, with the base, as I said, we are still using water because sodium hydroxide is water soluble. So the reagent showing water in presence of OH minus, or if I show it as NaOH, these two are the same. Why? Because the sodium hydroxide is prepared in water, okay? It's prepared in water. So showing NaOH or showing water in presence of OH, those two are the same. Now, when I see an OH in there, this means that this is a basic medium. So my product that I'm going to form has to be a base, okay? It has to be a base in there. So what I'm going to do over here is that I'm going to break the carbonyl, the CN bond. This is the amide bond in there. So whatever part is left over here, I'm just going to move it to the side. And I am going to add now my reagent. And my reagent is an OH minus in this case, so OH and Na plus. So I am adding an OH. So all what you need to do over here, see that OH? You just go ahead and make a bond and add the OH. So that is the same OH in there, okay? Plus whatever you have left in there, whatever you have left from this amide, you just go ahead and write it over here. And whatever I have left here is the nitrogen connected to the CH3 and connected to the hydrogen. Guys, when nitrogen has 2 bonds and 2 lone pairs, please look at the formal charge table. Then this needs to be a negative charge, okay? Now, we're going to stop and think over here that our medium is a base. You see that? This is a base. This amide is dissolved in a base. It doesn't make sense that if you have a base and you have an acid in your product, this is after all a carboxylic acid. So what happens here, this is not the final product. What happens here, I know that this guy is a base. So that base is going to come and take this acidic hydrogen in there. And I'm going to end up having my final product, which is going to be the base of the acid. So that is going to be negative charge plus my hydrogen here. The base took another hydrogen and then a CH3, and it became a neutral in this case. So that is going to be my final product. Let's have another example. So if I have something like this, if I have a carbonyl, a nitrogen, and 2 CH3s, I'm doing hydrolysis in presence of a basic medium. So I said like I can either show it as water in presence of a base, or I can show it as NaOH. Whatever representation you want to show, it's the same thing. So for these reactions, we're going to always break the amide bond. And what we're going to do is we're going to add the OH. We're going to replace the N and the 2 CH3s by the OH. Okay, so here you go. And the reaction goes over 2 steps. So that is going to be the OH. The OH comes from this OH over here, which is this OH over here. Plus, of course, whatever is left over of the amide, which is the nitrogen and the 2 CH3s. I have a CH3. These are the 2 lone pairs and the negative charge. This is a base, and the medium is a base. It is not an acid, so I cannot form the acid. So the base will come and take this hydrogen, and I'm going to be left over with my end product in there, which is the base of the acid. So you should show the base of the acid and the counter ion that is balancing it, which is the CH3, another CH3, and the hydrogen, and this is a neutral. These are the final products of this reaction. The last reaction is the formation of nylon. Nylon is a type of plastic that is a polyamide. And so far we know how to make polyamides from acid chlorides and amides. But if we start with a diacid chloride and a diamine, we make a polymer. Now we know that to make a polymer, you need monomers, n number of monomers, a lot of monomers, meaning that you combine together to make a polymer chain. Here in this example or in this reaction, I'm using two different types of monomers, not the same type, two different types. So I'm going to call this monomer 1, and this one is going to be monomer 2. And those are found n times, meaning there's a lot of them in the solution. So the reaction happens as such. When they arrange in the solution, the diacid chloride is going to lose a chlorine, and the diamine is going to lose a hydrogen. So in this case, what I am losing is an HCl molecule here. This is a small molecule. This is why these types of reactions, we call them condensation, polymerization, because in condensation polymerization, you just take monomers, you condense them together, and you end up losing a small molecule in the process. The small molecule here in this example is HCl. So just think about it, that n molecules of diacid chlorides are reacting with n molecules of diamine, just arranging like that. So you're going to lose a chlorine from here, a hydrogen from there, and then you're going to go ahead and lose a hydrogen from the diamine from the other side, and then you're going to lose a chlorine if there is a diacid chloride over here, and so forth. And in the process, what you're doing is you are making an amide bond. The amide bond is going to be from the carbon of the carbonyl to the nitrogen every single time. Okay, so let's go ahead and draw the polymer repeating unit. You are starting from here. So that is going to be, I'm going to draw the polymer repeating unit here. The polymer repeating unit is going to include both monomers in there. So that is going to be a carbon double bond O connected to the CH2, that is 4, and then a carbon double bond O. We lost a chlorine here. We lost the hydrogen there. We made an amide bond between the carbonyl and the nitrogen. So that is the amide linkage. So this bond over here is the amide linkage that we made. And this is why this is called a polyamide. And then the rest of the molecule. And then I do have an NH. That's it. And I'm going to stop here. So it's going to be an NH. Let me move it to the down in there so that I can show it better. Here you go. Okay. Let's take this bond in here. So we have the NH, and that's it. So that is going to be the polyamide repeating unit. Okay, make it like that. And that is going to be the polyamide repeating unit of nylon.